Hi, everybody, and thank you for joining us today for our live webinar, Know the Code, Understanding Building Code Compliance. My name is Kim Melton, and I'm going to be the moderator for today's presentation, so thank you for joining us. Joining me today are Eric Makela from Cadmus and John Elverum from Johns Manville. But before we dive too deep into our presentation and to our introductions, I would like to go over a few logistics. First, we're going to conclude the webinar with a live Q&A session. So if you have any questions throughout this presentation, you can actually submit them via the Q&A box on your screen. And if you don't see that, you should see a small square in the top right corner of your screen that says Q&A. If you click on that, it'll open a dialog box that you can use to submit questions. So in addition to that, we're also frequently asked whether or not we send out these presentations upon their conclusion. And that's actually not something that we do, but we do record the presentation. And so you can actually send copies of that and links to that to your colleagues within its full context. So this is all really part of how we deliver the JAM experience to you. And basically at Johns Manville, the JAM experience is part of our culture, and it's based on 4 pillars, and that's people, passion, perform, and protect. Now, we offer webinars like this to help educate the market and offer a tool and a resource for you and your business. So we're continuously striving to improve and evolve these webinars. So if you have any comments or suggestions as to how we can better accomplish this, or even if you feel like maybe we've missed the mark today, we definitely encourage you to fill out the survey that you're going to receive at the end of the webinar. And we use this feedback that you give us to improve our webinars and provide information that has the most value to you. So on that note, let's get to introductions. John, if you could take a few minutes to introduce yourself.
Hello, this is John Elverum with Johns Manville. I've been with Johns Manville for 11 years, and I provide technical support primarily for a number of the mechanical insulation products. And I'd like to introduce the co-presenter, Eric Makela with Cadmus.
Thanks, John. Hi, this is Eric Makela from Cadmus Group, and I am our team lead for our Codes and Standards team. I've been involved, as this says, for over 30 years in building energy codes, starting actually with California's Title 24 and then evolving into the International Energy Conservation Code. And I've been heavily involved in code development on the IECC for the last number of years, either serving on the committee, code development committee, or representing the Northwest Energy Codes Group, or ResNet, on the code development floor. I've also been, from a Cadmus perspective, been involved in several energy code compliance studies, looking at both residential and residential and commercial compliance issues, and I'm hoping to share some of that with you today as we move through the presentation. John, can we go to the next slide, please? So Cadmus overall we're really a multidisciplinary firm, and our codes and standards team is part of our energy sector, but we also have several other sectors, and we're really a solutions-oriented company that works to improve people's lives, looking at safety and security and resilience, the environment, international development, transportation, health, and food and agriculture. So with that, let's jump into the meat of the presentation and start talking about code evolutions. So the slide, some of you may have already seen the slide about kind of the evolution of ASHRAE 90.1 from an efficiency standpoint over the number of years. And I'm putting this up primarily because ASHRAE is referenced in the International Energy Conservation Code. So you can either use the IECC or you can use ASHRAE 90.1. As you can see, there's been, but from ASHRAE 90.1 2004 down to 90.1 2013, which is the last published ASHRAE, there's been a significant increase in efficiencies. Between the 2004 and the 2007, there was roughly a 5% increase in efficiency, and between the 2007 and 2010, we were looking at roughly a 25 to 28% increase in efficiency. So a significant amount of efficiency, and a lot of this was actually driven between 07 and 10 by an ASHRAE, or not ASHRAE, but a U.S. Department of Energy push to get a code that's 30% more efficient than ASHRAE 90.1 2004. So, and it's important to note too that all aspects of the building actually played in increasing the efficiencies over time. The 2013 standard is out, and that picked up a few more percent. So we're continuing to increase the efficiencies over time at the ASHRAE standard. So if we can go to the next slide, John. if you look at the IECC, essentially the IECC followed the same trajectory as the ASHRAE standard. And if you take the 2006 IECC as the base case, which actually referenced ASHRAE 90.1 2004, that became the base case on measuring equipment or measuring efficiency for the IECC. And so the 2009, basically we had about a 5% increase over the 6. The 2012 had one of the largest gains ever in kind of the young life of the International Energy Conservation Code, about a 25% increase of efficiency over the 2006. And that was a significant gain. The 15 came in with another maybe 8%. There were some things added on the mechanical side and that type of thing. And then this 2018 that's just been published in September, I'm guessing we've probably picked up another 5, maybe 6 to 7%. The U.S. Department of Energy has not done an analysis that I've seen anyway to show what kind of an efficiency gain we got between the 2015 and 2018, and now actually we're starting to look at the 2021. So it's kind of we're continuing to push on this. If we can go to the next slide, John. So it's important to note that all parts of the building systems, energy-using systems, actually contributed to these efficiency gains. Obviously, envelope is a major player on this, and over the time there have been significant increases in insulation efficiency requirements, things like requiring continuous insulation on metal and wood frame wall systems, better metal building insulation, but really kind of focusing on increasing the insulation levels in all parts of the building, more slab edge insulation, for example, that type of thing. There's also been increased fenestration efficiencies because obviously glazing plays a major role in building energy efficiency depending on how much glass you have. So the U factors for glazing and solar heat gain coefficients have been drastically increased over time, especially since the 2006 code. And there's also reduced the amount of glass that you're allowed to have down to 30% prescriptively in the IECC. New to the code is something called a continuous air barrier. So now in residential, we've always focused on the envelope, sealing that up and doing testing. On the commercial now, we require a continuous air barrier, and there's a few options of meeting those requirements. So from an envelope standpoint, again, we're trying to increase the efficiency of the envelope as much as we can moving forward. Certainly on the mechanical and surface water heating side, we've had better equipment efficiencies requirements now. A lot of control requirements that are brand new into the code or fairly new into the code to make sure our systems are operating at peak efficiency at all times. And then we've just added over in the 2012, the requirement for HVAC commissioning to make sure that all the controls and the systems we're installing are actually operating as designed to maximize efficiency. For lighting systems, the lighting power densities, or how much lighting you're actually allowed to be able to install, have dropped to increase efficiencies. And this is based on LED technology, just better lighting technology that's out there right now. So our lighting numbers are actually getting more efficient. They're going down. So that's been a big swing for lighting savings. With also more controls, more automatic controls, things like daylighting controls, occupancy sensors are now required and actually mandated in certain areas. And there's a lot of synergy between the lighting systems and the building envelope as far as glazing placement. Now a requirement for envelope to actually install skylights based on large roof areas and put in automatic daylighting controls. So the lighting and the envelope really play a lot together in the IECC. And then something unique to the International Energy Conservation Code option packages. This is to give you a little bit more efficiency after you comply with the prescriptive requirements. So you have several different options. For example, putting in a better lighting system with a lower lighting power allowance, or a better mechanical system with an increased efficiency HVAC systems, a better thermal envelope, actually increasing the insulation levels increasing the putting in better windows, so a better UA on the envelope, and also a tighter envelope because they're finding significant energy savings if you tighten up the building shell, and that gets back to our continuous air barrier requirements. And then the ability to put in renewables to offset the energy use of the building. So these are some of the major changes that we've seen over over the last number of years from an IECC standpoint. So now, John, I'm going to turn it over to you to talk about recent insulation code evolutions.
Thank you very much, Eric. With the code changes, what I'd like to do is touch on several examples of the implications for code change, how it has an impact both on manufacturers like Johns Manville and other insulation manufacturers, as well as contractors for installing those products, architects and engineers that have to design within those spaces. The first example I'd like to talk a little bit about is materials that are permitted in a plenum space and how the code language has changed for that. The second example will be the change or the increase in insulation thickness for steam piping. And then the third example has to do with insulating ducts that are buried in attic or ceiling insulation. The first example involving materials in a plenum space, for the slide that's showing, we give a description from the International Mechanical Code as far as what is a plenum space, and that's the verbiage is at the top of the slide. If you look at the photo itself, you can see that there's a number of mechanical systems that are involved in a plenum space. And a lot of times those different surfaces, the pipes, the HVAC system, have to be insulated. There's a number of reasons that we insulate. In a plenum space that might not have conditioned air in it, and so it's subject to the climatic conditions outdoors, we might have to insulate for freeze protection for some of the water piping, maybe sprinkler piping. Energy savings and process control. We put a lot of energy and effort into being comfortable within our buildings. And so we want to make sure that we're as efficient as possible and saving energy by insulating those various systems within a building. Condensation control is a concern in plenum spaces for non-conditioned air, where you might have below ambient air piping or ductwork that might be subjected to hot and humid conditions where condensation might occur. So insulating those systems to minimize the potential for condensation is definitely something that is done throughout the U.S. Fire safety, if you're putting materials into a plenum space, you don't want them to become fuel for the fire in the event of a fire event. And lastly, if you have people working in a plenum space around steam piping, hot ducts, you want to make sure that they're protected so that they don't get burned. So again, another reason for insulating those mechanical systems in a plenum space. In 1998, the International Mechanical Code had very straightforward language as far as materials and what was required of those materials in a plenum space. The definition here states that the materials either needed to be non-combustible or have a fire hazard classification rating of a 25 or less flame spread index and a smoke developed index of not greater than 50 when tested according to ASTM E84. And this fire hazard classification is something that you will see like in the International Mechanical Code for sure. As we move forward into 2009, the verbiage within that section of code changed. They still had the initial requirement of the 2550 fire hazard classification rating, but now dealing with combustible materials in a plenum space, the code had exception 5 that required those combustible materials like piping to be enclosed within non-combustible raceways or enclosures, or within materials listed and labeled for such application. And the words listed and labeled are emphasized in the code. As we move forward into 2015, emphasis is placed on listing and labeling. So now it's in the primary section of that section of code, the primary paragraph, and continues to be in exception number 5, where materials installed within a plenum space have to be listed and labeled for that application. in addition to having that 2550 fire hazard classification rating. The definitions from the International Mechanical Code for listed and labeled are presented on this slide, and I'd like to draw your attention to the bottom half of each definition, where in the case for listing, it states that either that the equipment, material, product, or service meets identified standards or has been tested and found suitable for a specified purpose. This same language is listed below for labeling, and that gives some options as far as materials in a plenum space that not only in addition to being either non-combustible or having a 2550 rating, but they need to be listed and labeled according to a third-party entity, such as Underwriters Laboratories, Unitech. And so what has changed? The biggest thing has to do with the intent and wording of code over the years. The emphasis on the words listed and labeled within the code that is becoming more specific as far as the material application. And then as far as the application, is it going to be something that requires a fire hour rated construction, or can those combustible pipes and surfaces within a plenum be insulated with a material that's just 2550 rated, that's listed and labeled for that application? The next example has to do with a code change involving the thickness for steam piping. In 2006, just 2 thicknesses were required. If the pipe size was less than or equal to 1.5 inches in diameter, the insulation thickness was 1.5 inches. If your pipe size was greater than 1.5 inches in diameter, then your insulation thickness needed to be 3 inches. Moving forward to 2015 with the energy savings requirements required by either ASHRAE 90.1 that Eric alluded to, or the International Energy Conservation Code, insulation thicknesses increased. Now it was double the insulation thicknesses for pipe size less than 1 inch. It now needed to be 3-inch thick insulation. 4-inch thick insulation for pipe sizes 1 inch to less than 1.5 inches, and 4.5-inch thick insulation for steam piping less than or equal to 1.5 inches in diameter. The implication here is that you needed much more space for your insulated pipe. Going down the bullet items, 2006, a 3-inch steam pipe, which was required to be insulated with 3-inch thick material, had an insulated outer diameter of just over 9.5 inches. By 2015, this increased to 4.5-inch thick insulation, increased the outer diameter of the insulated pipe to 12.7 inches for this example. So there was an increase in 3 inches in diameter required for the space for that insulated pipe. And if you recall the photo of the plenum space that has the mechanical distribution systems running through it, a lot of times that space is not planned for and it can be a real issue. The 2 bottom bullet points show that there's about a 20% savings in heat loss with that change in insulation thickness from 2006 to 2015. The third example for insulating buried ducts, up until 2018, or in fact the middle of 2017, it was not recommended to bury HVAC ducts in the loose fill insulation in an attic or a ceiling space if it was a below ambient air system, like running air-conditioned air in the summer, because there was a concern that the insulation on the ductwork would be cold enough to allow moisture vapor that had diffused through the permeable insulation to condense. If a condensed liquid moisture could allow condensation to occur, odor issues, mold issues, that sort of thing. However, with the code changes, the different industry organizations like NEMA looked into the situation and ran some tests to see if, in fact, insulated ducts or ducts could be buried within the ceiling insulation and get some benefit for the ductwork for the insulation that was automatically in the ceiling space. And the testing showed that they could control condensation or the propensity for condensation to occur if the following was done. One was to have the supply and return ducts insulated with insulation that had an R value that was equal to or greater than R8 with a vapor retarder facing, and that the ceiling insulation that would be in contact with the ductwork, either against it or above it and or below it, needed to be at least an R19, excluding the R value of the duct insulation. If this application was followed, then it was very, very unlikely for condensation to occur in almost all circumstances, like hot and humid conditions down in the southern United States. So the implications here are that now the HVAC ducts don't have to be located above the ceiling insulation. They can retain a little bit of benefit for the ceiling insulation or the attic insulation. The one caveat is now it might be a little bit more difficult to locate those buried ducts in that attic space if somebody has to service some of the utilities there. Okay, I'll turn it back to Eric now regarding issues that can cause systems to fall out of compliance.
Great, thanks, John. So the two things I'm going to focus on in this next section, one are kind of looking at what some of the compliance issues are that we're finding out there, and the other is where I think energy codes are going, and especially from a building envelope perspective. And again, this will just kind of be my opinion, basically looking at the industry and figuring it out. But Cadmus has done several energy code compliance studies across the U.S., both on the residential and commercial side, just to see what problems and issues are out there, look at compliance rates and that type of thing. And we're starting to see some trends. Obviously, there's you always get things that are not quite right. But if I had to kind of summarize where some of the compliance issues were focused, these are the key four elements that I'd say really kind of drive lack of compliance in commercial energy codes. So the first one is actually there's no energy code documentation being submitted on plans, and this happens in some areas where people don't submit documentation, and so you don't know if the building actually complies or not. You might get a statement on the plans from the designer saying that the building complies with all code requirements of Title 20 or of the IECC, whatever version it's going to be, but there's no documentation that really supports it. And the energy code, there's actually a section in there that essentially that says you have to provide documentation in some way, shape, or form that actually demonstrates that you've complied with the energy code. Sometimes this is for the envelope, just a cross section through the building that with leader arrows, it points out to the different R value requirements and maybe a glazing schedule that shows U factor and things like that. But oftentimes you don't see that. There's just no documentation whatsoever, and in that case you don't know whether or not the building complies or doesn't comply with the code, or if they used a trade-off approach that didn't get submitted with the plan. So that's a big issue. The next issue is probably you might get some documentation but not all documentation. So maybe the mechanical and electrical designer submit documentation showing compliance with the mechanical and lighting requirements, but nothing from the architect for the building shell, or the architect submits something but one of the other subs doesn't do that. And again, you're not sure if the other parts of the building comply or not, but this is a big issue. And again, this can lead to non-compliance with the code. Lack of proper documentation for field installed features. Probably the biggest black hole that we've seen so far out there is the lack of NFRC labels for site-built windows that actually show you the product that's being installed. And that's the biggest thing that we've seen, and it occurs over and over and over again. But there's also things like, not knowing what R value of insulation has been installed in the wall system, or lack of documentation on continuous insulation in the roof deck. Maybe that's not inspected, for example, before it gets covered by the roof membrane, so you don't really know. The other issue that we see over and over again is for slab edge insulation on slabs for commercial buildings that don't go all the way up to the top of the slab surface like they're required by code if you're going to take credit for it. This isn't a labeling issue, it's just an installation issue from these types of products. And I think that as John was going through his slides, one of the things that popped into my mind is our codes are becoming more complex, especially on the commercial side. He showed the difference between 2 thicknesses of insulation for piping. Now we have 4 thicknesses of insulation based on pipe diameter. We have new technologies or new methods of construction for insulating buried ductwork, but that's on the residential side. But on the commercial, our commercial codes are kind of becoming significantly more complex as new technologies come out, as new methods of saving energy come out, and it is a lot to keep up with as we move through here. So the lack of understanding of commercial code requirements is a big issue because you're in a constant training mode to figure out exactly what the code requires to make sure you can actually meet it. We have the newest thing in the code for an envelope is continuous air barriers, and people are still, that's going to take a lot of time and effort and energy to figure out how to comply with that. So if we can go on to the next slide, please. So all this being said, we've got, we've talked a little bit about the progression of codes from an efficiency standpoint. We've talked a little bit about, at least on my side, the problems with compliance in the field and what some of the issues are that are causing it. But now I kind of want to take a look to see where I think codes are going, especially from an envelope perspective. And again, this is after being in the code development process for a long time and looking to see the types of changes that have happened over the last number of years. I think ultimately where I think we're going is we're going to be heading toward zero net energy. And right now we're already seeing this in states. California, for example, has already got they're setting their targets on zero net energy. Oregon the governor just put in a mandate that buildings will be ZNE the next number of years. You have a lot of zero net energy types of policies being adopted in other states in the Northeast. So we're starting to see this. From a national codes perspective, though, I think what's going to end up happening is that these state level mandates will trickle up to the national level, and ultimately the IECC and ASHRAE 90.1 will get there. We have no idea how many years that's going to take, though. This is going to be a kind of a work in progress, but I think ultimately the more we can do to increase the efficiencies of the whole building envelope, mechanical lighting system, and other uses in that building, the closer we're going to get to a building that actually can take effective use of PV and that type of thing. So if we can go to the next slide, please. From an envelope standpoint, where do I see things going? Probably the first thing is building envelope commissioning. We currently have requirements right now for commissioning for mechanical systems, functional testing for lighting controls, and also commissioning for surface water heating systems, but building envelope commissioning, essentially making sure that the continuous air barrier is installed properly, you're using the right products, things are sealed between, making sure that insulation's installed properly, completely fills the cavities of the building to make sure that you're getting the full efficiency values out of those products. I think this is going to be the next push. When this is going to happen, I'm not sure, but I think this could be the next code change proposal that you could see coming in to try to get potentially in the 2021 code. If we can go to the next slide, please. Talking about the continuous, let's see, from an insulation standpoint, there's already been a push in the codes for continuous insulation. That seems to be the most effective place to install insulation on metal and wood frame walls, and the R value tables that are in the IECC tend to kind of promote that fairly heavily. So There's a lot of thermal bridging that happens in commercial building construction that I think we're starting to be more and more aware of. Certainly some of the states are already addressing this within their state developed codes, but it's eliminating a lot of the thermal bridging, and that's best done oftentimes by putting on continuous insulation. So I can see kind of more of a movement toward making our assemblies more efficient through continuous insulation. And if we can go to the last slide in this series. The other part is on increasing the effectiveness of our continuous air barriers. The code currently allows us to install kind of pre-approved building materials or pre-approved building assemblies, or do testing for the building envelope to see if you actually meet the air leakage requirements. I am envisioning, and actually this almost happened in the 2018 code, that we will be requiring all buildings to be a blower door test done to meet the maximum leakage rate for the building assembly. What I have in front of you right now is actually taken out of one of the code change proposals submitted by the U.S. Department of Energy, to basically that requires different occupancy types based on floor area to test. To make sure you've actually met the minimum or maximum leakage requirements in the code. So this is kind of the proof in the pudding, and it's already required on the residential side. So I believe we're going to see this in the commercial code requirements too, coming up fairly soon, actually. So with that, John, I'll turn it back over to you.
Okay, thank you very much, Eric. One of the potential code changes that was being considered in 2017 that had implication involved a residential restriction on flex duct. This was, it's governed by the International Association of Plumbing and Mechanical Officials, involving the Uniform Mechanical Code. In 2012, there wasn't a restriction on the length of flex ducts. However, by 2015, a restriction was put in place in commercial buildings. And I believe that the reasoning for that is that they felt like a lot of the installations for flex duct, particularly when they were long, is that they tended to be crimped, compressed, so that they weren't very efficient. So the code change in 2015 of commercial buildings, there was an exception that there was not a restriction on the length for flex duct for residential occupancies. However, in 2017, there was a proposal that was going to limit the length of the flexible air duct and air connectors to no more than 5 feet in length for all residential occupancies. So this went through the code process where there's quite a bit of dialogue as far as what is being proposed and counter-proposed, and there was implications for manufacturers of flex duct if they would be restricted in that market, and for contractors too, because then it would become more difficult in certain residential occupancies to kind of hardwire metal ducts into place through trusses, around piping, ductwork, that sort of thing. And so we learned about a week and a half ago that based on the discussions that took place, that proposal was not approved. And at least right now in 2017 going into 2018, the Uniform Mechanical Code will not have that restriction for residential occupancies. And now I'm going to turn it back to Eric regarding the driving forces behind some of these building code changes.
Great, thanks a lot, John. And this is kind of the last segment in the presentation. So, you know, I think that if you've never been involved in the code development process, I think that the perception is that this is a very congenial process where where every 3 years everyone gets together, they set goals for where they want codes. And I'll focus on energy because this is the biggest thing here that I'm seeing. But you would get together every 3 years. You would set your goals and your targets towards saying, yeah, we want a code that's X% more efficient. Whether that's 5 or 10% or something like that. And then you all of industry gets together. They start looking at code change proposals. They discuss them. They analyze them. They actually all agree on them, and then you submit them, and they come into the code. And in a way, this is actually how the ASHRAE standards process works. The International Energy Conservation Code is a little bit different. It is a government consensus process that allows anyone to submit a code change proposal, regardless of whether you're increasing efficiency or decreasing efficiency. The ultimate say on what gets in is actually the voting members of basically the members of the jurisdiction that are voting members of the International Code Council. They will kind of have the ultimate say on what actually gets into their codes, and then once it's in a code, then the jurisdiction can adopt to use it. But in theory, this is kind of, I think if you haven't involved, this is maybe how you think that this actually works. If we can go to the next slide. In reality, the code development process is not for the faint of heart. And there is a lot of good work that's being done in the code development process, but I think the best analogy to use is trying to get a bill through Congress. You start off with an idea, you float this idea out to everyone, people have a chance to comment on it before the process even happens, you have people oppose it, support it, they like something, but they want it tweaked or changed or whatever else, and you submit this, and then you go to support your code change proposal on the code change floor in a kind of a two-stage process. There are always going to be people that oppose your proposal for whatever reason, and it's kind of the last. Some days it feels like the last man standing to get the code, get a code change proposal into the code. It'll be heard in front of a committee of industry experts, and then it's heard in front of the overall General Assembly, and then it's actually voted on after that. So there's a lot of good ideas that get left on the code change floor. There's a lot of bad ideas that get left on the code change floor. Ultimately, we end up with the code that we have, and again, this is all voted on by the government consensus. So this has been going on for years and years, and it actually works. We do have a code right now, again, that's significantly more efficient than the first version of the International Energy Conservation Code that came out in 1998. So we have come a long way since that time. It may not work as fast as people would like it to work from an efficiency standpoint, but then again, we're constantly scrambling to keep up with code changes. So, but the process does work. It's just you have to learn how to do the process. So if we can go to the next slide. I think some of the issues that people see with the current process is, for one thing, there isn't a stated goal. States right now that develop codes will look at and say, we want to get to 70% of the energy use of a baseline code by 2030, for example. And so the state process directs the code that direction, and you can do incremental changes in order to meet those codes. Or someone sets up a zero net energy requirement to say we're going to be all zero net energy, for example, by 2024 or 2026. You kind of pick the date. Again, that's a state-driven process, and the code will evolve within that state to be able to meet this the goals. The international codes don't have stated goals. They're not in the International Building Code, Mechanical Code, Plumbing Code, Energy Code. They're not there. So this allows anyone to submit changes, to tweak, modify, change, to either increase efficiency or decrease efficiency. And so this makes it unpredictable as far as the type of changes you're going to actually get every cycle from the IECC standpoint, both on the residential side and the commercial side. And the next part is that right now, after the big push that we looked at on the graph that showed a 25 or 30% increase over our baseline codes, industry all kind of backed that. Some not happy about it, but they just assumed that it was going to happen. And there's not an appetite for that kind of an increase in efficiency anymore from a code standpoint. So things moved incredibly quickly. We got a lot of efficiency very fast, and I think we're still playing catch up right now with our current codes, and it's going to take a while for everyone to come up to speed on that. So these drastic increases in efficiency of a 30% increase, the industry right now just they don't have the appetite to move that forward. And so I think that's why over the next couple of cycles we're going to see smaller incremental changes, probably still some changes, but smaller incremental changes. Tends to be more happening on the commercial side than on the residential side. So now let's take a look at the driving forces behind code development. And I thought about trying to how to summarize the reasons for getting involved in the process and what a lot of the reasons are. And you have kind of, in my mind, three different players in this. You have those that participate in the process that are kind of the honest brokers. They really don't care. They don't care how you get there. They just want increases in efficiency in the building. This could be envelope, this could be mechanical, this could be lighting, but they just want an overall increase in building energy efficiency, and there's no regard for product or placement, anything like that. It's like, let's just get it. And so you have those players on the floor. Then you have those that are trying to increase their efficiency for product placement. You want a product or a group of products to get into the code to increase efficiency, but you really want to do it with your grouping of products. And this we see, I think the IECC is probably the most product-driven code of all the codes out there. But you certainly want to you're trying to get something in the code that actually places your product in the ideal situation. You'll increase efficiency, but you're increasing it with your particular product or group of products. So, and the last but not least is either increasing or decreasing efficiency for protection of product. We have players on the floor that they start to see trends, they start to see issues, and they realize that if some of the requirements get in the code, their product is going to be obsolete. They may not be able to install it or install as much of it, so part of it is actually protection of market or protection of product. And you know, there are several ways of reaching the same goal, but you know, ideally, if I'm a manufacturer manufacturing Makela's widget, I want my widget in the code and try to get everyone to use it. Certainly, there are safeguards within the international code process that prohibit a lot of this to do, and there are some requirements as far as free trade and things like that. So there are processes in there that really eliminate a lot of this from happening, but still, you know, product placement, getting products in, protecting your product, that type of thing is a kind of a driving force that we see in the IECC code development process. So who's actually starting to do this from an envelope side or doing this from an envelope side? And I'm showing different manufacturer trade groups and that type of thing for envelope, and understand there's also a similar number of trade groups on the mechanical side and on the lighting side, service water heating. There's a lot of people represented on the floor. These are the ones that we see on the envelope side that are focused on this. And again, this is really only for insulation because we have a slightly smaller group that also deal with fenestration too. So you've got for example, the fiberglass industry that represented by NAMA and individual members, plastic insulation industry, the American Chemistry Council, and their individual measures. They are very active on the code development floor, promoting new methods of insulation, continuous insulation, that type of thing as new products come out and start to roll out. You have APA and the American Wood Council that are kind of focused on looking at cavity-only options for insulation, for example. They have a lot of good ideas. They again also have new products coming out that they'd like to see credit for in the code from an efficiency standpoint, but they're kind of looking to say, you know, let's focus on cavity-only options so we can all play in this market. Certainly, the Steel Framing Alliance has a voice in this too, because there's a lot of metal framed buildings out there and they need to be insulated, and so they're always looking to make sure that different ways of insulating their products. Metal Building Manufacturers Association, a lot of square footage of metal buildings, especially on the warehouses, and so they are again trying to make sure they're protected, and that they're also there's been some big increases in efficiency for the Metal Building Manufacturers Association over the years too. That was probably one of the larger changes in the IECC in the 2012. And then last but certainly not least is the Masonry Alliance that is looking at their products. Their masonry products, they play a role both on continuous air barriers, insulation, that type of thing, to make sure that they're looking at different ways of insulating and different allowances and things like that too. So for code development, these again are from an insulation standpoint the major players. And like I said, you've also got a section that deals purely with glazing and not the insulation side. So with that, that's my wrap up for the driving forces behind code changes. Before I turn this over to Kim, I'd like to just talk about one additional resource, an offer from Cadmus, if we can go to that slide. We do have a IECC PowerPoint presentation out on our website. You can get a free copy of this. This is on the 2015 IECC, not on the 2018, but there's not a huge number of changes. So if you're interested in looking at a half-day presentation on the 2015 IECC for commercial buildings, it gives you the highlights of what's going on in the code. Feel free to head out and get your copy at our website of energycodes.cadmus.com/IECC.workshop. And with that, I will turn this over to Kim. Thank you.
Thanks a lot, Eric. So I also wanted to talk about some additional resources that we have for anybody who's looking for more educational opportunities like this one. So the first one I'd like to discuss is JM Academy. Now, this is a series of free online training modules. They go over everything from an introduction to HVAC and mechanical systems to how to install Johns Manville insulation to the science behind fiberglass health and safety. So if you're looking for opportunities to get training or credits for training, this is a great opportunity to do that. The second one is our blog. Now, we both write and curate content for this blog. So that means we're not only relying on our own technical experts, but we're actually finding information from technical experts throughout the industry. Our blog topics hit on targeted technical information, the latest news you'll find in the industry, and even scientific details that are critical to the success of an insulation system design and operation. So we really strive to make this content as rich and robust as possible so that it can be highly relevant to you and the information that you need. And then finally, I'd just like to discuss the exclusive content section of our website. Now, this is where we host all of our recorded webinars, and this webinar today will also be hosted up here. You'll also find white papers, you'll find videos, and so on and so forth, and this is really a library where you can access a series of educational information that we have to offer at Johns Manville to really make it as useful to you as possible. So one other thing to note, we will be at the AHR Expo in 2018. That's going to be in Orlando, so we'll be at booth 5319. If you'll be there, we'd love it if you'd stop by and say hi. You can watch live duct bar demonstrations, and you can even check out what our products look like when they're actually installed. So with that, I did want to talk about the certificate of completion that we will be sending out at the end of the webinar. This is what you'll get. This is what you'll get in. In your email. Somebody just corrected me. The AHR show is actually in Chicago, not Orlando. My apologies. But we will get a certificate of completion sent out to you guys today for everybody who attended. So with that, let's dive into a couple questions. And our first question today says, I'm seeing more and more value engineering throwing out mechanical insulation, especially on plumbing, and then HVAC contractors are wrapping their own ducts, not to code in our area. How can this be combated in our area? Eric, do you have any insight into that, or John, do you?
From my point of view in handling a number of questions like this, the code talks about the authority having jurisdiction, and that might be the building inspector, it might be the engineer or architect or owner, and really it comes down to them and what they're requiring for the building and what they require of the contractors that are installing the different products and how they're installed. So I would point toward the building inspector, the authority having jurisdiction, that they need to do what they're supposed to do for that particular situation.
And I would agree. It really is up to the inspector on site to make sure that whatever's installed complies with code, whether the R value and also how it's installed. I mean, the codes are fairly clear about the installation of this and the products that can be used and that type of thing. So this could be an education process to the building departments. You know, they may not be aware of some of the insulation practices, but a lot of times this will fall on the shoulders of the inspector, and also, you know, the mechanical too needs to take a responsibility on this to make sure that they're actually doing it per code. But sometimes industry isn't aware of code, so they're used to doing it the way they've done it, and until they're told otherwise, they may continue to do it that way.
All right, thanks, guys. So our next question is, do building codes ever conflict with one another, and if so, which one should take priority?
So I'll take a shot at this. Theoretically, no. There is a codes correlation committee to make sure that this doesn't happen, and also through the code development process, these are the types of things that are looked at if you submit a code change proposal. So from a theoretical standpoint, the answer on that should be no. From an energy standpoint, there is a provision up in Chapter 1 of the code that basically says that health, life, safety takes precedent over energy. So if there is something that might conflict in one of the other codes that is a health, life, safety related issue, that would take precedent over energy. And every once in a while, something will pop up. You know, it's missed by something, and it's just, you've got, I don't know how many international codes there are right now, a whole lot of them, but, you know, every once in a while something will actually pop up and that is missed. But in general, I think in most codes do. I haven't run into very many conflicts over the years.
All right, thanks, Eric. So the next question is, regarding using fiberglass pipe insulation in plenums, can I only use JM insulation, or can I use pipe insulation from other manufacturers?
This is an interesting question. In my dealings with the International Code Council and building inspectors, they're looking for compliance to the language that's in the code. And so if a material is listed and labeled, whether it's Johns Manville or another manufacturer, then yes, it's my understanding that it could be used in a plenum space.
All right, great. Thank you, John. So the next question is, what should I do if the code is changed such that the materials that were previously within the code are now no longer code compliant?
I'll take a shot at that one. So codes are promulgated every 3 years. Essentially, we go through the process of code development, but they are not necessarily adopted by every state every 3 years. So you could have the most current code might actually prevent your product from being installed, but you really need to look at the code that is adopted by the jurisdiction that you're working in. And it could be an earlier code that allows you to put the product in. So it really is going to be dependent on what the code the jurisdiction has adopted, whether or not you can actually install that particular product. But again, it takes, for energy, for example, it does take a while to, we have the 2018 publish right now, and we're starting to see some early adoption of that code in some of the states, but there's a lot of states that are still on the 9 and the 12 and the 15. So so you really need to, again, take a look at the code that the jurisdiction has adopted to determine whether or not your product can be installed.
All right, thanks, Eric. This next question is actually about installation, and that is, contractors in our area disagree over whether insulation should go on prior to supporting the duct or after the duct is supported. Which do you recommend?
That's a good question. A lot of it just depends on the trades and what they have gotten used to over time. I think for most of the information that I've seen, normally the ductwork would be supported, and then the insulation contractor would then work to that, rather than doing his work and having somebody else, a different trade, come back and cut into his insulation, disrupting his work. Ultimately, the installing contractor, the trades that are responsible for installing the ductwork or the piping, have to warranty their work. So if they have a preference, they should make it known. And I don't think that there's necessarily a best way or just one way necessarily in every circumstance. So the trades definitely have to work together, and they have to work together with the engineer and building inspector that will be overseeing that particular part of the project.
All right. Our next question is, will the drive toward net zero energy buildings be impacted by the political climate?
Good question. I think nationally, the Department of Energy, again, they were a driving force behind the 30% increase in code. And I don't think that from a national perspective, you're going to see that out of the Department of Energy now. I believe that politically, certainly some of the states have started to take this on, and so that's been more of a political move. For example, California and Oregon. I know there's others I'm not mentioning that, but California and Oregon tend to jump into my mind. Those are kind of focused at the state level, and those are obviously very political. So yes, I think that it's nationally. I think it's going to be difficult to get there on the IECC standpoint. State level standpoint, I think we'll be getting there in more states than the IECC, but ultimately I think it'll trickle up or kind of percolate up, as I talked about earlier, that ultimately I think it will get into the IECC and ASHRAE. So.
Excellent. Thank you, Eric. That actually wraps up our questions for today. So as I mentioned at the beginning of the webinar, as soon as you close out your screen, it's going to be followed by a survey, and we'd really appreciate your feedback today if you have anything to offer. Also, if you come up with any questions that you maybe didn't get a chance to submit, or you'd like to have us respond to you directly via email, go ahead and fill out the survey, and we can actually do that via your comments in the survey. Also, please keep an eye on your inbox for that certificate of completion. We're going to send that out by Friday by Friday this week. And then over the next couple of days, we will get this webinar posted to our exclusive content portal. So if you want to listen to it again or feel like it might be beneficial for any of your colleagues, you're certainly welcome to forward the link on to them. So with that, thank you very much for attending today. We hope you found the information useful and relevant. So if you have any questions, don't hesitate to reach out to us or Eric, and we'd be happy to answer them. So we will hope you have a great week. Thank you. Bye-bye.